Okay, hello friends, welcome to my lecture. This is mathematics lecture for grade 12. So under this lecture we are going to see what sequence means. So here is my outline for today's class. So first we are going to see what sequence means, and we will see also type of sequence. Basically there are two types of sequence. Those are arithmetic sequence and geometric sequence. So we'll try to see one by one, and I'm going to also evaluate some exercise on both this arithmetic and geometric sequence. So let's start by defining what sequence means. So sequence is nothing but it is a list of numbers, but whose domain is a positive integer. That means the value of n must be positive integer. That means it starts from 1, 2, 3 and up to positive infinity. So here is notation of sequence. Sequence can be expressed or described just by using three methods. So the first one is just by listing the term. So as you see this example, this sequence is listed just by this way. So we can describe or just we can express sequence just by listing the term like this, and we can also express or describe a sequence just by writing the general term like this. So this sequence can be expressed as a general formula like this, and the other one is just by drawing the graph. So we can express the above sequence just by drawing the graph like this. So if we use the horizontal axis as n, that means a domain for a sequence, and if we use a vertical axis as a sequence an, so if I put 1 here, 1, 2, 3, so as I told you, n must be what? Positive integer. That means 1, 2, 3, 4 and continue. So if we substitute 1 here, we obtain what? 1. So if I put 1 here for an, 1 here, so it is 1. So I can point here 1. And what about if we substitute 2 here? 2 an, also what? 2. That means if I put 2 here, so 2 and 2, so I can point here. So it's also the same for other value of n. We can also see this example. So if we have a general formula an, we can also draw the general graph for any sequence. So for instance, for this example, minus 1 the power of n over n, if we substitute 1, we obtain what? Minus 1 the power of what? Minus 1 the power of 1 here over what? 1. That means is minus 1. So you can see minus 1 here. This is 1 for n value 1. We obtain what? Minus 1 for an. And also we can also substitute 2 here. So minus 1 the power of 2, that's 1, because negative number the power of even number, that is positive number. So 1 over 2, that is around 0.5. So you can see here it is 0.5. So we can express sequence by just using these three methods. So now let's see the first type of sequence, that is an arithmetic sequence. So arithmetic sequence or arithmetic progression can be defined as one in which the difference between two consecutive terms is a constant. So this constant, what we call it? Division. That means the difference between two consecutive terms. So we can obtain D just by subtracting the first term from the second term, or we can also use A3 minus A2, but in general we can use the formula for finding or obtaining the constant D just by subtracting an minus 1 from what? An. So here is a general formula for obtaining an arithmetic sequence. So here is an, that means nth term of a given arithmetic sequence. An, that means the first term for a given arithmetic sequence, and D is it's what you call it a division or a difference between two consecutive terms. So a sequence can be arithmetic if only if the division should be what? Constant. So if I take an example, a n equals to, if we describe a sequence just by listing the term, 1 here, 3, 5, 7, that means it's a set of odd integers, and continue. So if we try to evaluate the division D, so we can use either this or this. So if I subtract the first term from the second term, I obtain what? 3 minus 1, that is 2. And if we use these two terms, that means 5 minus 3 is 2. And we can also use this, the last two terms, that means 7 minus 5, that is 2. So as you see, the division of the difference is constant, so we can say that this sequence is an arithmetic. And also you can obtain what? The general formula for this given arithmetic sequence. So from the given we can obtain A1 as what? A1 means a first term for a given sequence, so it can be obtained as what? Just by using the first term, that means 1 here, and a division, that means a difference between two consecutive terms. So we can use this formula in general. So D can be calculated as 3 minus 1, that is 2. 2 here. So that's good. So if we have these two terms, we can obtain a general formula for a given arithmetic sequence. So an can be obtained as what? Obtained as an which equal to what? A1, that is what? 1 here, plus n minus 1, that means n minus 1 here, times what? A division D, that is what? 2. So now let's simplify this equation just by multiplying 2 by n, that is 2n here, minus 2 times minus 1, that's minus 1, minus 1 here, what? No, that's not minus 1, sorry, it's minus 2. Minus 2 what? Plus what? 1 here. So it can be further simplified as 2n what? Minus 1. So this is what? The general term for this given arithmetic sequence. So we can check that this is a general formula for the above sequence. So we can just put 1 here, 2 times 1, that is 2 minus 1, so 1. So you can also check for the rest one. So in order to find the general term for any arithmetic sequence, first we have to find the first term and what? The division D, just by subtracting two consecutive terms. Okay, here is another exercise on this arithmetic sequence. So it says, given an arithmetic sequence whose first two terms are -3 and 7. So here is the first two means, that means A1. The first two terms means A1 what? And A2. So A1 is here and A2 is here. So the question says find the next three terms. That means the next three terms means A1 and A2 is already given. So the next three terms means A3, A3, A4, A4, and what? A5. A5 here is, and the 14th term, that means A what? 14, that is 1 4. A14. So as I have told you, for evaluating a general n term of an arithmetic sequence, first we must obtain what? The division and A1, but A1 is already given, that's -3. So we can define the division D just by subtracting the first term from what? The second term, that is A2 minus A1, yes, A1 here. So these two terms are already given, so we can just substitute this 7 for A2 minus 3 what? For A1. So this can be obtained as what? 10. So now we have the first term, which is A1, and the division D. So we can obtain what? The general n term for this arithmetic sequence just by using a formula, that is an equal with what? A1. That means -3 here. Put -3 here. What? Plus n minus 1. N minus 1 here. Times a division, that is 10. So this can be simplified as what? 10 and here minus what? Minus 10 times -1, that is -10. So -10 here, and this is -3, so -3. So this can be further simplified as 10 and minus what? -30, that is 1 3. So here is a general formula or a general n term for the above arithmetic sequence. So now we can obtain a value for A3, A4, A5 just by putting what? A value of n, 3, 4, 5, whatever. So if we are going to find the third term, that is A3, we can put 3 here. So 10 times 3, that is 30, minus 30, that is what? 20, no, 1, 7, that is 17. So we can also obtain A3 just by using what? A3 means what? A2 what? A2 plus what? a division D, that is 10. So it is already given as 7, so this can be calculated as 7 plus what? Plus D, it is 10, so 7 plus 10 will be what? 17, that is 17. So the third term is obtained as what? 17. So we can also add 10 here to just find or to obtain the fourth term and continue. So now let's find what is the value of the 14th term. So instead of finding each value of an arithmetic sequence, it's better to use a general formula for obtaining this 14th term. So A40 is just calculated by using this general formula. So we can put 14 on n, so 10 times what? 14 here, what? Minus 13, that is 13. So this is 10 times 40, it is 140, minus 30, it is calculated as what? 127. So you have to keep in mind, so for such type of question, first you have to identify the first term and the division D. So if you have these two terms, you can obtain n's or n's general formula for any arithmetic sequence. So this is the second type of sequence, what you call it, geometric sequence. So this sequence can be defined as a sequence one which the ratio, that is, it's a ratio between two consecutive terms, must be what? n0 constant. Yes, for arithmetic sequence or for arithmetic progression, we see the difference, not the ratio. But here we need to see what? The ratio between two consecutive terms. So this ratio can be symbolized as what? R. Yes. So a sequence, whether or not a geometric, this ratio must be what? n0 what? n0 constant. So this constant is called, what you call it, a common ratio. So it can be obtained as what? Just dividing gn plus 1 over what? Gn, or in general R can be, that means a common ratio for a given geometric sequence can be calculated as Gn what? Plus 1 over Gn. So we can substitute any value of n just to find what? R. So if we substitute 1 here, R can be calculated as what? G2 over G1. That means we can obtain the common ratio just by dividing the second term to the first term. So this is a general formula for obtaining a geometric sequence. So this nth term for any geometric sequence can be calculated as in such a way. So Gn equal with R, that means a common ratio for a given geometric sequence, R the power of n minus 1 times the first term for a geometric sequence, that is G1. So let's do some exercise on this type of sequence. So it says decide whether or not each of the following sequences geometric, and for those that are geometric, determine the nth value. So here there are two questions. The first one is just to identify whether a sequence is geometric or not. So as I said, a sequence, it is to be geometric if and only if what a common ratio r should be n0 constant. Okay, so r can be calculated as what? G2 here, it is G2 over G1. That means dividing the second term to the first term. So G2 it is -2 here. So put -2 on the numerator, -2 here over this 1 here. So this can be obtained as what? -2. And if we use G3 and G2, R can be calculated as 4 over -2, that is -2. And you can also use the last two terms, that means -8 and 4. So -8 over 4, we can obtain as what? -2. So as you see, this common ratio R is constant for each. So we can say that this sequence is geometric. So the general nth term can be calculated as Gn can be calculated as r to the power of n minus 1. R to the power of n minus 1 here, n minus 1. Yes, times what? The first term, that is G1. So we can put the value of R and G1. G1 means the first term of a given geometric sequence, that is what? 1 here. So Gn can be calculated as R, it is -2 here, so we can put -2 here, the power of n minus 1 here, n minus 1 here, times what? G1, that is 1. So times what? 1. So, or we can cancel 1, so a number times 1, that is a number itself, so -2 the power of n minus 1. So if we put 1 here, 1 minus 1, 0. Any number or any variable, the power of 0, that is 1. So as you see, 1, 1 here. And also, if we substitute the value of n as 2 minus 1, that is 1, and to the power of 1, it is -2. So we can conclude that this nth term is a general formula for this listed sequence. So we can say that this sequence is geometric. So let's continue for B. It says 5, 5, 5, 5, 5, and continue. So as I said before, first we have to check the geometric just by calculating the common ratio R. So it can be calculated as just by dividing the second term to the first term. So 5 over 5, that is 1. Yes, and also if we use these terms, that means R can be calculated as 5 over 5, that is 1, 5 over 5, that's 1, 5 over 5, that's 1. So as you see, this common ratio R is constant for each terms. So we can conclude that this sequence is what? Geometric. Okay, so Gn or nth term for this sequence can be obtained as what? Gn. That means nth term for this listed sequence can be evaluated as what? R, it is 1, so put 1 here, the power of what? N minus 1, n minus 1 here, times what? the first term, that means g1. So we can use this as a first term, so times what? 5. So 1, the power of any number, that is what? 1 itself. So 1 times 5, this is 5. So for any value of n, a sequence Gn is 5. That means this geometric sequence Gn is independent of its domain. So G1 it is 5, G2 it is 5, G3 is 5, and continue. So this can be what? Geometric sequence. So let's continue for C. So first, let's check whether a sequence is geometric or not just by finding or just by calculating a common ratio R. So R can be calculated as by dividing the second term to the first term, that is 0 over minus 2, that is 0. So as I told you, a sequence is to be geometric if and only if what? A common ratio R must be what? N 0 constant. So we obtain 0 here. Yes, so it is not geometric sequence. And also we can take for another terms. So 2 over 0, that is not defined. So we can say that this is what? Not what? Not geometric sequence, because the common ratio R is not what? Constant. Geometric. This sequence is what we call it? Not geometric sequence. Okay, this is not geometric sequence. And D it says 9 minus 3, 1 minus 1 over 3, 1 over 9. So now let's find a common ratio R just by dividing this term to this one. So minus 3 over 9, that is what? Minus 3 over 9, that is what? Minus 1 over 3, yes? Minus 1 over 3 here. And also, you can also check just by using the third term and the second term. So 1 over minus 3, that's minus 1 over 3, minus 1 over 3 over 1, that's minus 1 over 3. So we can say that this sequence is geometric. And also, a general instant Gn can be calculated as just by using the general formula Gn equal with what? R is, it is minus 1 over 3. So put minus 1 over 3 here, minus 1 over 3, the power of what? The power of n minus 1, that is n minus 1 here, n minus 1 here, times the first term, which is what? 9. Yes? 9. Yes? So this is a general formula for this listed sequence. So now we can check the first term just by substituting any value 1 here. So G1 equals to 1 minus 1. 1 minus 1 means 0. Any number or any variable, the power of 0, which is 1. 1 times 9 is 9 here. And if we are going to check for the second term, so put 2 here, G2 equal with minus 1 over 3, the power of 2 minus 1, that is 1 here. So if we sub G2 here, G2 which equal with what? Minus 1 over 3, 2 minus 1, that is 1. So minus 1 the power of 1, that is minus 1 over 3 times what? Times becomes 9. So this can be simplified as if we divide 9 by 3, we obtain what? Minus 3 here. So this can be a general formula for this listed sequence. So it is the end of today's class. So please share, subscribe, like my channel to get more videos. So thank you.